Hello. In this video we are going to talk about calculating the maintenance cost. We're going to calculate the cost per year, the total cost, say the cumulative cost, and the average cost per year. We're also going to put them into graphs, and we are going to use some mathematical formulas. And of course my favorite, names, using names. Are you ready? Let's get started.
Alright, we're going to calculate now the maintenance cost. The standard cost per year are 1000 and we give this a name. And the name we give SC. Why SC? Well, it's familiar with standard cost. The other one is increase every year. It's the abbreviation of increase every year. For the years we take an X value and for the cost we take an I value. Why is that? Because we are going to use some math and the equation in the graph will be X and I value. Alright, now we are going to give names to it. Now we select the range for the values and the names and then we click create from selection. The names are not in the top row but are in the right column. So there are the names in the right column. Click OK. And we also give names to the years. The years are the X values, so we select this range including the name X. Create from selection. And now Excel sees that the name could probably be in the top row. So we leave the tick mark as it is. Click OK. Now the next step is that we check our results. Click in the name manager. And I used names in previous sheets. So I filter this for my worksheet. And I see now that I have those three names. 200, 1000 and the years 1, 2, 3, 4, 5. Alright, now we can continue. Let's calculate the cost for the first year. We make a reference to the standard cost and you see the reference is not D3 but it's a reference to the name SC, standard cost. For the second year we have the cost of the previous year plus the 200. We select the cell D4 but you see it's displayed as IEI. Now we can copy this down and we have our results. Let's check the last formula, of course. Double click and we see that we make a reference to the previous cell and to the cell D4 say IEI. Alright, now what are the cumulative costs? So for the first year it's of course 1000 and for the second year it is the previous year plus the cost for the second year. We can copy this down and we see that the end result is 7000. Let's check this. Yes, it's the previous year plus the cost of the fifth year. Alright. What are the average costs per year? Well, if we have 7000 in 5 years, then on average we have 7000 divided by 5 years is 1400. We copy this and we see our result. And the results looks fine. So the next step is that we can make some graphs. Okay, we have to make a graph. What kind of graph would be the best? Well, of course an XY diagram. Because we are going to see that we are going to express the I value, say the cost, in terms of X, say the years. So let's select the years and the cost, click insert and click for charts. We select a chart where we see only the dots because the line we are going to add later. Alright, we're going to make some modifications for it. First of it, the size. Yeah, we're going to put the graph here. Alright, the next step is that we make a chart title. We click in the chart title and then in the formula bar we make a reference to the cell where the title is. In this case E7. Oh, that's not okay. That must be an equal sign, of course. Enter. And we have the cost per year. Alright, then the X values, we have to change them. Double click on it and then we come in the a menu for format axis. The maximum value is 5 because we have 5 years. And the major step is 1. Okay, that's enough. And we remove this window. Alright, now we are going to make a line to it, a regression line, so we can see what is the relation between the values for the years and the cost. We right mouse button, we add a trend line, and in our trend line we choose for a linear trend line. We also make the equation in the chart and the R squared. Why the R squared? Well, if it's 1, it means that all the dots are perfectly on this line. If it's not equal to 1, we might have to choose another kind of line. And we see the relation 200x plus 800, which is not the same as the 1000 here, but we'll come back to that later. I'm going to explain why this equation is there. Now let's first make a copy of it. Control C, Control V, and we put it here, Control V as well. Now, what is very nice about these graphs, if I put it this way, if I click on the graph, I see where my X and my Y values are. So the only thing I can do here is that I move the I values to the right and I have different I values. Now, we see a straight line, we see the cost, and we see that the R squared is 0.99. Maybe this model is not good enough. Maybe this equation does not display exactly the reality. So let's change it. Right mouse button, form a trend line, and we do choose now for a polynomial. Order 2, and all the other settings we can leave in. Close it, and this is our result. I equals 100x squared plus 900x plus 7e minus 12. Well, this is a very low number. It's a scientific notation and you can ignore it. You can actually read it as 0. But what we see is that the R squared is 1, and that means we have a perfect line on it. So later we are going to explain why this equation reflects these numbers. Alright, the last one, the cost per year is not sheet E7, but it is J7. So we change here the E for J, enter, and we have the total cost cumulative, and in this case we are going to change also some lines. So the average cost, we move the X values, the I values, and we have our value here. And this is 100x plus 900. Again, we are going to explain this. Alright, so we have 3 different equations, of course, because they are different. This is the cost per year, this is the total cost, and this is not the total cost, it's J7. So we change the E for a J. Enter. Alright, we are ready for our next step. Are you joining me? Alright, so the next step is to translate the mathematical equation of the regression line into an equation that uses our names, our variable names. Well, let's try to put this. The total cost, or the cost per year, is the cost is I equals, and then the first value is 200. Well, the 200 must be the IEY. We multiply this with X, and then we add, I put it into brackets but that's not needed, the standard cost minus the increase every year. Enter. And this is a formula. And now watch. I'm going to copy this, Control C, Control V, and I put it here. Make it a bit wider. And then what I'm going to do is I'm going to delete the Y and the space, so I only have the formula. And you can see already that it refers to cell D3 and D4 with the names, and to the X. And Excel understands that if this is a whole range with X values, you only take the value in the same row. Enter. You see this result. Copy this down and we see exactly the same result. So in this case we use our logical formula by using the fields here, and in this case we used also a formula. But we got to this result by reading the regression analysis. And this is a very cool technique how you can make your formulas. We call this check. Alright, we will do this also for the total cost. Let's see if we get something the same. And it's a bit difficult. We have 100 multiplied by x squared. The 100 will be half of those 200. 900x, that must be 1000 minus half of those 200. That is at least something that we expect. We're going to type it in and we're going to see if this is true. So I equals 0.5, comma or point, depending on where you live, multiplied with IEE, multiplied with x to the power of 2, plus, bracket open, standard cost minus 0.5 multiplied with IEI, and then this whole thing must be multiplied with x. So multiply with x. Enter. Alright, we have to do some modifications here. The 2 behind the x is something we have to subscribe. So we press Ctrl 1 and then we say superscript. Okay. So now we have a formula here which actually looks the same. Let's see if we can copy this. I think we have to do some modifications when we see this. Ctrl C and Ctrl V. Enter. Let's delete the I and the equal, enter, and we get a result. The result is not the same. Why is that? Well, it has to do with in the formula bar with the x2. We have to do this to the power. So we have to add something here and we make it to the power. Enter. And then we get the same result. Let's check if we can copy this down, and we have the same result as in our regular formula. Now watch the difference between the formula. This is based on the mathematical equation of the regression line, and this is based on our logic. Alright, next step then, the average cost per year, which is not so difficult anymore. We type in equal 100, equal 100. 100 is half of increase every year. 0.5 multiplied by increase every year multiplied by x plus, what do we have to add? 900. 900 is the standard cost minus half of increase every year. So we make a bracket just for optical reasons, not necessary from a mathematical point of view, and we type in standard cost minus 0.5 multiplied by IEA. Enter. Alright, this is our last result. Let's copy this again. Ctrl C, Ctrl V, and we are going to delete the I and the space. Enter, and we get a result. Copy this down and we have the same result. Now again, check the formula based on the mathematical equation and check the formula based on what we did in our previous model. Okay, so we are almost done. Our last step is check. Check, check, double check. Now what do we check? We check what happens if the parameters change. Now let's first delete the increase in year and put it to 0. What does it mean? All the years the costs are 1000. Let's see what happens to the graphs and the figures. If you look at the graph, you see that the costs remain on the level of 1000 and the total costs are a straight line, proportional increase every year. And of course the average cost also remain the same every year. So that's okay. Now put it back to 200. And now let's see what happens if the standard costs are 0. That means we only have an increase of 200 every year. Let's see what happens then. We press enter and we see that the cost per year increase every year with 200. We see that the total costs still are exponential, and we see that the average cost every year increase also by an amount of 200. So we put it back in our original values, and I thank you very much for watching. I hope you liked it, and I see you next time. Bye bye.